Andreas, and with my group of Sama, Arapti, and Haewon Kang, we will be talking about pacemakers and the electrical properties of the heart. So quickly about what is a pacemaker. So it's a small device that is placed in the chest or abdomen to help control heart rhythms. And those heart rhythms are called arrhythmias. So that means that the heart is beating at an irregular pace. That can either mean too fast, too slow, or just irregular in its rhythm out. When we use physics, we are essentially using a low energy electrical pulses to prompt the heart to beat. So we're going to be replacing the irregular heart pulses with these electrical ones. And the way that we give these electrical pulses is through delivering them in a circuit in the heart.
Hi, I'm Helen Kang, and I'm going to be talking about the cardiac conduction system, or from here on out from the presentation, it'll be called the CCS. So a group of smooth muscle cells surround the heart, and they signal the heart to pump. And the mechanisms that allow an electrical signal to go through the heart and allow the contraction and the relaxation of the muscles include the SA node, the AV node, the bundle of His, bundle branches, and Purkinje's fibers. The SA node is known as our natural pacemaker, and it's like a node that's found in the right atrium. It sends an electrical signal over to the AV node, which is on the right side of the right atrium, and that allows for the contraction of the smooth muscles of the right atrium that pushes the incoming blood into the right ventricle. The pathway of the signal from the SA node to the ventricles, it's stimulated by action potentials. And as you can see, the SA node would be found right here in the right atrium, and then the AV node would be right here. The electrical signal from the SA node to the AV node would cause the contraction of the muscles right here and cause the blood that enters from the superior vena cava into the right atrium to be pushed into the right ventricle. This can be seen in an EKG or ECG as the P wave. And then the very large R wave would be seen as the right ventricle releasing the blood into the pulmonary artery, or having the ventricle muscles contracting hard enough to push it outside of the heart.
So multiple reasons as to why somebody would require a pacemaker would, as Ariana previously covered, be the misfiring in the cardiac conduction system. So this would include illness, such as in the SA node, which is basically our natural pacemaker. So obviously that would, be a threat to our heartbeat and our heart rate. And then there's also the heart block, which is just messing up in the electrical impulses in the heart, and sort of those messages not being transmitted correctly or being blocked in the atrium or in the atria. And then there's tachyarrhythmia, which is just one form of having an irregular heartbeat. Basically, tachyarrhythmia is going to be a speedy, kind of fluttery heartbeat, but any irregular heartbeat could be solved with a pacemaker. So the pacemaker is made out of electrodes and a pulse generator, and here in this diagram, as you can see, it's a really simple mechanism. So it has simply a battery and circuitry and a connector block within a case, and what comes out of that is the lead, which is the area that goes into the heart and which will send those electrical impulses. And this area will actually sit near the clavicle area, and the lead will actually go into the heart through the atria or the ventricles, depending on the kind of pacemaker that it is, which I will talk about later. And what the pacemaker can do is it's often mixed up with the defibrillator. So what the pacemaker does is it will solve for irregular heartbeats, but it actually can't restart the heart. So what it can do is just correct those electrical impulses and keep the pace steady and normal. Unlike a defibrillator, which can actually restart the heart in case it stops. So the pacemaker is good for, staying alive, but it's not going to resuscitate a patient. And this is just a basic diagram to show how the pacemaker is in the heart and where it's located. So as you can see here, there's the case which will sit right there underneath the clavicle, as I said previously, and this is where the electrical impulses will be generated from. And here, as you can see, the lead goes in through a major vein and will enter through the atrium and will sit right there in the ventricle. And as Helen previously showed in the anatomy of the heart, where the SA node is, it's going to sit in that vicinity, and it's going to generate those impulses. So the pacemaker, it can detect heart rate and your breathing rate, and it can, some advanced pacemakers can determine exactly how much oxygen you need, so that they can modify the electrical impulses in order to stimulate correctly. So it'll measure also the voltage of the heart. It's actually a sensor of sorts. So it doesn't just send those impulses, it also senses the body's conditions and senses the correct stimulation to send to the heart. So they're very sensitive, though, as the current and the voltage in the heart is really, really small and really minimal. So the pacemaker needs to be sensitive to those impulses and be able to interpret them. If it's not sensitive enough, it won't get a clear enough message from the heart, and it won't be able to do its job correctly. So, and because it's so sensitive, other devices can really easily interfere with the pacemaker's functions, and we will talk about that later in the presentation. So electrical noise will obviously interfere with the pacemaker's ability to send electrical impulses to the heart. So there's 3 types of pacemakers. There's single chamber pacemakers,